This video is part of a larger project, where I rebuild my burnt down house. I have started to repair the foundation of the house, but had to stop as all the paperwork takes time. Even though I built the previous house, all the permits have to be submitted again, and it takes a long time for everything to be approved and ready. So in the meantime I'm repairing everything around the house, such as the foundation and the deck that partially burned down. I recommend that you watch the entire video before you start building. If you want it to be professionally correct, all steps must be done in the right order. I have been a carpenter for over 25 years, and have built a lot of houses and other things. When you have worked for so long in a profession, you know most tricks and shortcuts. I thought I'd show you how I build, and hopefully you'll learn something if this is new to you. When I build something, I like to do it cheaply and as quickly as possible. For me, it's about being efficient and always thinking one step ahead. When I say cheap, we don't choose inferior materials, but we make sure not to leave any waste pieces and not to buy too much material. Speed comes from well thought out moments and planning. A deck is a good example, as I build in a way that is quite unusual but very effective. Unlike many others, I work in reverse. I build the deck in the air and the footing is the last thing I do. I also make sure to measure in a way that means I take minimal measurements and saw as little as possible. Let me explain. Usually when you build a deck, you do the footing first, and then you build the frame and finally the floor. This can be difficult to achieve as all measurements must be perfect from the beginning, and that takes time. Especially if you are new to all this. There is an easier and faster way. If you turn it around instead, and build the frame with temporary supports, and then the floor, and finally the footing, you will save a lot of time and unnecessary adjustments. This means that you have freer hands to make changes at the last moment and that you do not have to adapt to the fixed measures. The deck I'm building is a bit different and very high. But I will make temporary supports first, and then cast the footings later the same way I described. Before we start, we can talk a little about the materials and tools we will need. You don't need advanced tools to build a deck. In this video we use a miter saw, electric screwdriver, jigsaw, circular saw, handsaw and a chalk string. The electric saw should have a guide rail, so that we can cleanly cut all the edges. If not, you can use a board as a ruler, but the result will not be as good. A chalk string is used to produce straight lines over long distances. This is an important tool and will be used a lot. We may also need a spirit level when building the frame. And that's all, we don't need anything else. You cannot use ordinary wood for an outdoor deck. Instead, choose a pressure-treated wood of good quality. When I frame the deck I use 170 by 45 mm wood, which corresponds to about 2 by 8 inches. You can use any measurement you want, but keep in mind that the thinner the wood, the more footings are needed. I have about 2 meters or 6 feet between my footings. Here in Scandinavia, we have built decks with similar materials and dimensions for decades, but things change and people are heavier. If you are building a standard deck with normal weight people, you can build as in this video, otherwise you have to choose thicker material or tighter studs. For deck boards I use 28 by 120 mm wood, or 1 by 5 inch. The length is important and we will cover that later. For deck railing I use 45 by 45 mm or 2 by 2 inch. And 45 by 70 mm or 2 by 3 inch. And for deck railing posts I use 70 by 70 mm or 3 by 3 inch. You can use thicker wood if you want, but I think it looks nicer with thin proportions. I prefer screws when building a deck. Nails are usually stronger, but for an ordinary deck, screws will be fine. Remember that they must be for outdoor use and of good quality. The dimensions of the screws I use are 6 by 100 mm or 4 inches for the frame, and 4.2 by 55 mm or 2.2 inches for the rest. You also need screws or bolts to attach the frame to the house or wall. Depending on how your deck looks or is to be used, joist hangers may be needed. I don't use any fittings at all in this video, as I can screw from any direction. This leaves exposed screw heads, which doesn't bother me at all. The first thing we have to do is draw up the entire construction on paper or in a computer. I will start with a regular square deck as mine is a bit too complicated for this video. It is always a good idea to first draw the construction so that we know how much material is needed. The frame of a deck usually looks the same with standard measurements. You have a stud that attaches to the wall and an identical one at the front. Between, you lay out studs exactly as in the picture and with one or more support lines under them. If you are going to use the space under the deck, you can have built-in support lines instead. And screw them without any joist hangers if you like, simply fasten the screws in an angle. Make the outer frame exactly how you want it. After that, we will calculate the material consumption, and it is in this situation that we can save time and money. In Scandinavia, we use a measurement method that we call a CC measurement. We take, for example, 60 centimeters and measure from center to center. I'm sure there are similar methods in the rest of the world but couldn't find any information about it. Anyway, our timber is usually based on that, so we can buy timber in the right length. The beauty of this method is that if we measure correctly, it goes much faster to build a floor, roof or deck. Let me explain for those who don't know. The deck I'm building is about 8.4 meters long or about 27.5 feet, so I choose as long deck boards as possible. In my case, I have ordered 4.8 meter long boards or 15.75 feet. If I divide it into 60 centimeters or 23.62 inches, the board will be supported on 8 studs, and end up center to center at the end. When I build the frame for my deck, I measure 60 centimeters back edge to 60 centimeters back edge, which is a CC measurement. If I lay out my studs the same all the way, my deck boards will always end up center to center. So a standard measurement of boards in Scandinavia can be 4.8 meters or a measurement that can be divided into 60 centimeters. If I put on the next board, I will have to cut it at 8.4 meters. I will then lay the remaining board on the next row and it will end up center to center again. After 3 rows the measurements to be cut will be the same, so I can cut everything ahead of time and just lay it all out. In this way, I cut minimally and get the right measurements again and again. It's hard to explain but very easy once you get the concept. There's quite a bit more to go through to speed up the work, but we'll cover that later. We will also build a frame around the deck as well as railings and more. If you understand the CC concept, you can easily calculate how much material is used. You can also calculate screws per square meter or inch. In my case, I need about 6 pieces of 100mm screws or 4 inches for each stud, and about 25 smaller screws per square meter. If we use the example that I drew in my computer, I would calculate the material in this way. For the frame, I first count the outside and the support lines. Thereafter all the joists that are laid out CC 60. If I divide the length of my deck, which is 8.4 meters with 0.60, the result will be 14 joists 3.9 meter long minus 1. I will try to find joists as close to that measurement as possible. Otherwise, I can splice them with nail plates. I will also take a few extra meters just in case. Calculating the consumption of deck boards is easy if we use the CC method. We just take the width of the boards and divide it by the number of square meters we need. We can take a few extra meters or feet. The idea is to get minimal waste pieces. Remember to first see which lengths are available so that you can adapt to your CC measurements. The deck railing is about 1 meter or 3.2 feet in all directions. The deck post is 1 meter above the deck and then down to our footings. We only need footings every 2 meters. The same applies to the 2x2 studs and the 2x3 studs. 1 meter or 3.2 feet in all directions. The railing itself is made of the same wood as our deck boards. I recommend that you use post holders between the wood and your footings. Wood should never be against concrete without anything in between. Finally, order concrete for the footings and some screws. It can be a bit difficult to work out how many screws are needed, but you can break it down into frame, deck flooring and railing. For example, 8 large screws for each joist, 32 smaller screws for the deck boards per square meter, and 8 larger screws per railing compartment. And so on. Let's start with the frame. Fasten a stud to the wall of your house. Then build the frame. In the middle, we adjust with a CC measurement that we get by dividing the length of our floor boards or using standard CC measurements. Since I am repairing an old deck, I already have footers at the front, so I have to follow those measurements. I will lay the floor from front to back, but I recommend that you do the opposite, start from the house outwards. To know how long the porch should be, you can add up your floor boards so that you get the right length, minus about 2.5 centimeters or 1 inch. So that the last board sticks out a little. For example, 33 floor boards, times 12 centimeters, minus 2.5 centimeters. Then the frame will be a total of 393.5 centimeters long. Depending on your wood, you may sometimes need to increase the measurement slightly as you want about 2 mm or 1/16 inch gap between the boards. A 2 mm gap gives a gap of about 5 mm when the wood is dried. The gap is there because the wood can have different widths when it is damp. Without the gap, you cannot adjust the boards if the measurements start to wander in some direction. We'll cover that more later. So if your wood has a different width, you should increase 12 centimeters to maybe 12.2. You can also put up 10 boards with a good gap and measure how much it will be, so you can see more precisely. I usually lay out some of the boards so I can have the saw close to the work area. When the frame is ready, we start laying out our floorboards. This takes time and can go completely wrong if not done correctly. As the wood is different widths, the wood can wander off and become crooked. Start from the wall out, but make sure that the first board is straight by following the house wall or using a chalk string. Lay the board center to center and save the last piece that we will start with the next round. We will fix the edges later with a nice frame. This is important. When you lay the first board, it must go under the panel, or something that protects against rain. We don't want water to find its way back to the house. We also need a capillary breaking layer between wood and wall. Without it, the moisture from the deck board can damage the house frame. You can use roofing felt as a barrier, or other breathable material. In normal cases, you lay one board at a time with a gap of about 2 mm. I don't do that. The reason is that one of the sides will start to creep away so that the last board will be completely crooked. Another reason is that it takes an unnecessarily long time to lay the boards. There is a better and faster way. Take 8 boards and lay them out temporarily with a gap of about 2 mm. Then take the total measurement, which is 976 mm in my case. Measure 976 mm on both sides and mark with your chalk line. Now you can cut all the boards in between. Do not fasten the boards yet, just lay them out. Then take the last row and fasten it after the marking of your chalk string. I prefer going down about 1 mm under the board. If you screw exactly level with the board, the screw will stick out when the wood dries. If you screw too deeply, water collects in the hole and can damage the screw. After that, you distribute all the boards in between and fasten them. In this way, you get straight boards and follow the correct measurements to the end of your deck. If necessary, you should cast the footings you cannot access before laying the rest of the boards. Do not cast footings along the edges, we want to do it last. The reason is that we can then change and choose the type of railing afterwards. You also don't have to worry about stairs and other details, we can do that later since we haven't decided where to place the feet or railings yet. That is one of the advantages of the reversed method. There are different types of footings. Choose the one that best suits your circumstances. If the ground is stable, you can dig a pit, preferably below frost level. Fill with gravel and pack well. Pour in about 10 centimeters or 4 inch of concrete and a concrete tube on top of it. Fill the concrete tube and push down a fitting. You can also use adjustable feet, ground screws, stone slabs or precast plinths. After the entire floor is laid, and screwed with at least 2 screws on each joist, we can start planning for the railing. There are different looks, but most are based on the same principle. Long posts every 2 meters or 6 feet, and 1 or more shorter ones in between. I like to have hidden posts, but attaching them to the outside works just as well, but gives a different look. The railing we build in this video is classic, cheap, and fits most houses. It costs minimal to build but looks very professional, which is a perfect combination. We will also build a nice frame around the entire deck, but we will do that after the railing posts are in place. Having hidden posts is a bit more complicated but looks more professional. We need to prepare a little before we move on. If you have your posts on the outside, you can actually just screw them directly into the frame and cast your footings afterwards. Use bolts instead of screws as your posts will be visible. Bring your posts down about 10 centimeters or 4 inches above the casting pipe. Attach the fitting and pour the concrete. Hidden posts require a little more work. I will start with the posts in front of the deck. I want around 1 meter or 3 feet between my posts, and an exact measurement so that all fence crosses are equal. To get the same measurements, we can use the CC method again. Before we put on the last 2 deck boards, we will fasten the posts inside the frame. The posts are 70 millimeters or 3 inches. If we measure half the post from the edge on both sides, we get the measurement between the center of our posts. In my case, the measurement is 8,286 millimeters. I divide it by the number of compartments I have, which is 8. The result is 1,035.75 millimeters as my CC measurement. Now you can measure from back edge to back edge, and all compartments will be exactly the same. When the front posts are done, we will do the same thing on the left and right side. If the measurements are different due to the distance, it doesn't matter. It can be about 10 centimeters or 4 inches different without you seeing it. But before we can put the posts on the sides, the boards have to be cut. And we have to do it right so that the frame fits. Let me explain. Earlier in the video we mentioned that the floor frame should stick out about 2.5 centimeters or 1 inch. We got that measurement by adding the width of the boards. The outer frame is the same as the floorboards, and 120 millimeters wide. So we need to cut the boards 95 millimeters in. After we have fastened our posts, we can cut them to the right length and then fasten the upper rail. I cut the posts about 85 centimeters or 33 inches from my deck boards. A regular handsaw gives the best results. The upper rail is also the same as the floorboards, and 120 millimeters wide. I let it stick out at the end and then saw the board in a 45-degree angle at the corner. I placed the top rail in the center of my posts. Then I attached the railing with 2 long screws for each post. Before attaching the screws, make sure that your posts are straight. You can use a spirit level for that. When I splice the railing, I make sure to end up in the middle of a post. I also make sure to cut the joint at 45 degrees as you can see in the video. The reason is that pressure-treated timber shrink. After the wood is shrunk, we can tighten the screws and avoid a gap in the joint. Now that the railing is in place, we can start with the deck frame. I prepare the last 2 boards for the posts, and cut them 45 degrees in the corners. As you can see in the picture, the left side has no support on any joist because we cut the boards. We have to make sure that both the frame and the boards are properly supported from below. You can attach a 70 by 45 mm or 2 by 3 joist between your posts to support your boards. And then something to support the frame. After the frame is in place, we can make all the crosses that will fit between our posts. As you can see, I have cut 2 spacer blocks of about 11 centimeters or 4.3 inches. I then cut a 45 by 70 mm or 2 by 3 joist that I fastened between the posts. By using spacers, the measurement will be the same between the next post. To attach the joist, you can use long screws that you screw through the post and into the wood. The next joist covers the screws on the right side. On the left side you can do the same, but then screw diagonally from above. The cross will cover that screw. After the lower joist is in place, I do the same with the upper one. I use spacers here as well. The last step is to make the cross itself. It may look complicated, but if you know how to do it, it's easy. Start by taking a measurement from corner to corner and add about 5 centimeters or 2 inches. Then cut a 45 by 45 or 2 by 2 joist. Place it behind the bottom and top joist and mark with a pencil. Now you know the angle of all crosses, and it will be the same between all posts if your measurements are correct. Set the saw according to your marking and mark the saw or write down the angle, so you can find your way back. We need to change the saw between cuts. Put the studs in place and make a similar one from the other side. Press it between the posts so that you have a perfect cross. Now you can mark the cross in the middle where the studs meet. If you place both studs next to each other, you have a perfect line that runs over the studs. If we cut out half of the studs on both sides, we can squeeze them into each other. To cut half of the stud, you have to set the cross angle in the same way as before. After that, you fold out a small stop screw that should be on your saw. The screw is set to prevent the saw from going too deep. After that, you saw several times between your markings until you can press the studs together. Press in the cross and fasten it so that the screws are not visible. Preferably from below. To speed up the work, I first saw all the studs for the cross, before I prepare them to be pressed together. Then I don't have to change the angle between all the cuts, and that saves a lot of time. Now we have come to the end of this video and I hope it is useful for you. I will post more videos where I build a modern house all by myself. I will also have tutorials on how to build furniture in old style but with modern methods. as well as an outdoor kitchen and much more. Please subscribe to my channel or leave a thumbs up if the video was helpful to you. I hope to see you in my next video.